from the homework. Number 5, how do you get the second time? Well, let's list what we know. We know that VI is 25. We know that VF is what? No. 18? Except, wait a minute, it said that the speed is 18. I think VF can be 18, but I think I could do a second situation where VI is 25 and VF on the way down is negative 18. A is negative 9.8, find T. A is negative 9.8, find T. The way you get both times is, since they said speed, not velocity, I guess that can mean on the way down too, which makes sense actually. It is at that speed twice, on the way up and on the way down. There's the 2 times. It also comes out, if you're using the d equals VIT plus a half AT squared equation, it's the fact that technically when you take the square root of a squared, it is actually plus or minus 2 possible answers, because it could be a positive or negative. That's also why you get 2 times. It's one reason why square roots have 2 answers, technically. Nature is saying it has to be that way. Is that okay? Yeah. Any others? So let's get to the fun stuff. If you get today, everything I do for the rest of this projectiles unit, which is fairly short, should make sense. So my message to you is turn your thinking caps on, really focus. Here we go. If you have the lesson done, by the way, please hand it in. If not, you got some homework. Lesson 2, horizontal projectiles. First of all, some terminology. An object that is launched through the air is called a projectile. That's our word for the day. I'll write that in once I get this going. There we go. Do that. And here's going to be our argument. See, a projectile is a very, very complicated type of motion. Incoming, catch, ready, and back. You'll notice it is not a nice straight line. And up until now, everything that we've looked at has been traveling in a nice straight line. What we're going to do is we're going to get clever. We're going to argue that when you're throwing a projectile, as opposed to dropping an iPod, when you're throwing a projectile, 2 types of motion are going on. There is a vertical motion, it's going up and coming back down, and there is a horizontal motion. We're going to break it up into components, which is why we always do vectors before we do projectiles. So we're going to think of 2 types of motions simultaneously. We're going to talk about horizontal, which I'll usually abbreviate with a capital H, and vertical, which I'll usually abbreviate with a capital V. And now I have to convince you of a few things. When you launch something horizontally as a projectile, the horizontal velocity, which I'll call Vx, x for horizontal, V for velocity, is constant. Because if I ignore air resistance, William, horizontally, my horizontal acceleration, which I think McKenna I'll call AX, is 0. Now, let me convince you of that. Pause the video for a second. This concept is key. It's important enough, I'm even going to put a little, hang on, that was supposed to be a highlighter, Mr. Dueck. Let's change colors. It's important enough, I'm even going to go donk, donk. If you understand that, that's going to be very important and useful. Oh, and it's always nice when something is 0, because that made most of our distance and velocity equations stuff canceled and became nicer. Okay. Oh, by the way, I'll give you a better convincing demonstration of that with some very good equipment in a little video I'll show you in a bit. Vertically, the vertical velocity is not constant because it slows. If you throw something, it slows down and then speeds up. In fact, I know the acceleration. What's the vertical acceleration of an object when you throw it? Negative 9.8. It's in free fall vertically. And what this means, Hakeem, is if I'm going to solve a projectile problem, I'm going to start by dividing the question into horizontal and vertical components. In fact, the first thing I'm going to do anytime you're giving me a projectile question, I'll draw a line down the middle of the page, I'll do a horizontal and a vertical column, and then I always write this. AX equals 0, AY equals negative 9.8. That means that Vx is going to be constant. It means that I'm not going to have a Vi and a Vf, because if Vx is horizontal speed is constant AJ, then my initial equals my final, equals my average, equals my halfway, equals my partway, equal, you know what? I drop the initial final notation for the horizontal section. Vertically, I will have a VI, a VF, and all that stuff. It means that here, the horizontal distance is that. What happened to the half AT squared? 0. Vertically, that's still the case. Vertically, that's still the case. And the key mistake, the common mistake, putting a vertical into a horizontal equation. Putting a vertical into a horizontal equation. Matt, the number of times that I'll see kids take a velocity from here and stick it into here, or an acceleration from here and stick it in here, or vice versa, but usually it's the most common. They want to put that negative 9.8 into an acceleration everywhere. And I'm telling you, if you're looking at the horizontal motion of a projectile, William, your acceleration is 0, which is nicer. Nathan's yawning, so we better move on. Example. A projectile is launched horizontally. You know what? Let's underline the word horizontally. Now, we start out launching horizontally from a cliff. Then tomorrow, we'll look at launching from the ground at an angle. We're going to break it up into components. And then in Physics 12, and we will look at it a bit this year, but it's really Physics 12, we'll launch at an angle from a cliff, because you need the quadratic equation to solve those ones, and we can't assume in Physics 11 that everybody has seen it yet. But by the time we get to grade 12, we do assume that everyone has seen it. Or else some of you will have to just teach it after school on the fly really, really quickly, and you'll pick it up very, very fast. Not mentioning any names, but we'll get there. Projectile is launched horizontally from a 92-meter high cliff at a velocity of 19 meters per second. A, how long until the projectile hits the ground? B, how far from the base of the cliff will the projectile hit the ground? Fancy word, we call this the range. The horizontal distance is called the range. I wrote DALP. What does DALP stand for? You really do want to draw a picture. So, cliff, there. What else do I know? I heard a mumbling, and I think they were right. Sorry? Which one? Where? What? Okay, because now I got to be fussy. There's horizontal and vertical distances now. Specifically in Part B, they're asking us for the horizontal distance. So, you know this? How high? What else? Riley? I think you said it. Okay, here is our velocity. It's going to look like this. Now, its path is going to probably trace, something like that-ish. I've thrown things from high places. That's what it looks like. But I'm not interested in that. I'm really interested in what's going on at the top and what's going on at the bottom. Is this a projectile? Everyone say yes. Then I'm going to go horizontal, vertical. I'm going to break this up into horizontal and vertical components. And right away, AJ, I'm going to say that horizontally, there's no acceleration. Vertically, the acceleration is negative 9.8. We're going to start pretty much every projectile question if there's a horizontal component. Now, last day, by the way, we looked at free fall. We were firing everything straight up. There was no horizontal component. We were careful to fire everything straight up and straight down. Now we're saying, okay, you got both. Do this. What else do I know? Well, now what I want to get are those two. By the way, why did I put an initial underneath the Vy, but I didn't put an initial underneath the Vx?
Because the Vx is constant.
It's not changing. I mean, you could. It's not wrong to say Vx initial, but I'm telling you, Vx initial is Vx final, is Vx... Okay. I can tell you what the horizontal velocity of this projectile is. The Vx. Look at my picture. 19. What about my vertical velocity? For a split second, right when I leave the cliff, if I'm going horizontally, which is why we underlined the word horizontal in the question, for a split second, right when I leave the cliff, how fast am I traveling vertically?
0.
I haven't started falling yet. My initial, temporarily, is 0. This is as though, William, you were dropping an object from the cliff. Oh, but also traveling sideways at the same time, and we're treating them totally separately. How many pieces of information do I have in each column right now? 2. I need 3 to find the 4th. So there has to be something else that they've told me. There is one more piece of information from my diagram that I haven't used. Huh? Which distance? Am I going to put that 92 under the H horizontal or under the V vertical? So I'm going to write this. How about dy for vertical? And you'll notice, McKenna, I'm really emphasizing x's and y's because I want to drum into my brain, don't you dare put a horizontal into a vertical. Don't you dare put a vertical into a horizontal. And maybe, AJ, maybe one of the ways I can do that is put x's and y's, and it takes almost no time at all. What is the vertical, and listen closely, please, displacement? It's not 92. Huh? What? Did you end up below from where you started from? It's that. If we're starting our timer right here and we're ending up below from where we started from, then, hey, if we're launching from a cliff, your displacement will be negative. Sorry, got to be careful. Your vertical displacement will be negative. Horizontally to the right is going to be positive. Which column do I have 3 things in now? That column. Now I'm committed. I'm going to solve the rest of this question vertically. And in particular, what I want to find is time. Why did I put the same T underneath both columns? Ah, good. You guys are starting to think right. The time traveling sideways is going to be the same as the time that you've fallen for. And almost always your goal is going to be to find time. In fact, if they give you the time, the question really falls apart. So I think I'm going to solve time vertically. I have A, V initial, D, and T. Which equation? This is also great final exam review. You may want your formula sheet out. I don't know. First of all, which equation before you rewrite it? D equals VIT plus a half AT squared. That one? Yep. Okay, let's write that down. This is complicated enough. I'm going to probably write, until I do a few of these, I'll write this out until I spot some patterns. I'm going to write dy equals Vy initial t plus a half Ay t squared. That's a terrible 2. Oh! What can I do? Conveniently, since that's a 0. Now that won't always be the case. Specifically, if you're launching it upwards at an angle, your initial vertical won't be 0, it'll be a component. But today, since the title of this lesson is Horizontal Projectiles, today it will be the case. In fact, what I really get is this. dy equals ayt squared over 2, because a half, same as a 2 on the bottom. What are we trying to find? Someone said it. You're right. Time. Let's get the t by itself. What will I do with that 2? Multiply. What will I do with that ay? Divide it, and then how will I get rid of a squared? So t is going to be 2 times d divided by a, I guess vertical and vertical, square root, which is the square root of 2 times negative 92 times negative 9.8. Now, if you missed that negative 92, if you wrote vertical distance instead of displacement, if you just put a positive 92, this is where you'd catch yourself, because you'd go 2 times 92 divided by negative 9.8, and when you tried to square root that, you'd get an error, and your calculator, nature is saying, I'm sorry, you've done something wonky. I can't actually answer this question for you. And probably you'd clue in and you'd say, I think I missed a negative somewhere. So there's kind of a built-in error check. Meanwhile, let's go to, insert a negative. Now I get a positive, square root of that. Do you have time of 4.33307? I'll go 4.33 seconds. What did part A want us to find? Time of flight? Okay, so over here, I'm going to go A, t equals 4.33 seconds. I'll even put a little box around it just so that whoever's marking this or whoever's wanting to know, I found it. By the way, up in my chart now, I'm going to fill in 4.33 seconds and 4.33 seconds. Now, why is that so nice? Look at my horizontal column. How many things do I know now? 3. You know what? If I got 3, I can find a 4th. What's B asking me to find? I think B is asking me to find dx. Well, I have A, V, T, and D. I'm looking for an equation that has distance, t, velocity, and acceleration in it. Why, it's the same equation we just used, except we'll put x's in there to remind ourselves horizontal, 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 horizontal. In fact, you know what? I'll even put a letter B there. I'll show my work right here. It's going to be dx equals vxt plus a half ax t squared. Oh! What? Now, Elijah said that 0, most common, by far, Elijah, even in my physics 12s, most common mistake, they want to put the negative 9.8 there. They want to put an acceleration. We're in free fall. We're in projectile. Yeah, vertically. But we're looking horizontally. And horizontally, if we ignore air resistance, there is no acceleration. It travels at a constant speed. By the way, that's why, for example, in the NFL, a wide receiver can get underneath a football and run underneath the football, and it appears to drop right into their hands. What they've done is they've matched their speed with the horizontal component. That's what they do. It's what an outfielder does when he's running down a fly ball. He matches his horizontal component to his horizontal speed to the horizontal component of the baseball until it drops into his hand. Which means, by the way, as humans, we're actually very good at estimating projectiles intuitively in our head, especially if we're athletic, even though we don't actually necessarily do all the math. We're just practice. Our brains are pretty impressive. What's Vx? Sorry? 19. Time was 4.33. How far away from the base of the cliff will it land? Conveniently, I have this more accurate 4.3333. Oh, I got that started on my calculator, so I'm just going to go times 19. It's going to land 82.3 meters away from the cliff. Even with air resistance, if you had like a cannonball, something round and heavy, you'd be accurate probably to within a couple of centimeters. Doesn't move that much. This is what we're going to be doing. You give me a projectile, we're going to break it into horizontal and vertical components. AX is 0, AY is negative 9.8 always, unless we're on a different planet, which we won't this year. And then think carefully, what's the vertical initial velocity? What's the horizontal initial velocity? They will give you something else, either a vertical or a horizontal displacement, or time. Turn the page. Example 2. A projectile is launched horizontally from a 123 meter high building at 12.2 meters per second. You know what? This concept of being launched horizontally is important. I'm going to underline that. Find, it says, the range. What's the range? Oh, you know what? Horizontal displacement. Dull. By the way, this question is almost identical to the one that we just did, except instead of walking you through saying, find the time, I just said find the range. But you know what I'm going to spend the most time doing? No pun intended. Finding t, time, because I'm going to need time to find the range. I'll convince you of that. Let's draw a picture. Uh, 123. 12.2. Horizontal and vertical. Oh, AX is 0, AY is negative 9.8. I've written something down. I feel better. My question's no longer blank. I know where I'm going. What else do I know?
Horizontal velocity.
Oh, Vx? What's Vx? I like that. What else do I know?
Vy.
I know Vy initial. I got to be fussy. I don't know Vy, but I do know the initial. What? What else do I know, Tanisha? You were right. Vertical? What is the vertical distance? Careful. It's not 123. Ah, negative. Right. By the way, I now notice I have one column with 3 pieces of information. That is now telling me that to find time, it's going to be vertical. And conveniently, the time is going to be the same over there. So to find time vertically, I'm looking for an equation that has AY, V. You know what? I think, again, it's going to be vertical equals vertical t plus a half a vertical t squared. I think once again, we can do that. I think we get the vertical displacement is going to be AY t squared over 2. I think if we get the t by itself, this seems very familiar. It is, I hope. It's going to be 2 times the vertical displacement divided by the vertical velocity square rooted. Which is going to be the square root of 2 times negative 123 divided by negative 9.8. What do you get? 2 times negative 123 divided by negative 9.8. Oh, it's going to be almost exactly 5, but not quite. 5.01-ish. T equals 5.01 seconds. Let's write that up here. 5.01 seconds. 5.01 seconds. That's not what they asked me to find, though. What did they ask me to find, Elijah? Range. Oh, they want me to find horizontal displacement, the range. Okay. Oh, I now have 3 things in that column. I can find the 4th. I think I can say dx equals vxt plus a half ax t squared. In fact, I think I can say that. And in fact, I think it's kind of plug and chuggish now. It's going to be Vx, which was, I can't remember, 12.2. Range, 5.01. Let's get clever. Answer times 12.2. 61.1 meters. This is the thrust of today's topic, today's lesson. All it means is I can give you different pieces of information. But our approach is going to be the same. Hey, let's try the next one. Example 3. Projectile is launched horizontally from a building at 32. It's the same question, Mr. Dueck. I don't know. Let's keep reading. If the range is 144 meters, how high is the building? Not quite the same question. I think in the previous 2 they gave us the height and they said find the range. Here they're giving us the range and they're saying find the height. Okay. You know how I'm going to start? I'm going to dulp and I'm going to break it up into horizontal and vertical. The approach is going to be the same. So here's my little picture. Oh, but this time I don't know the height. Oh, you know what? If I really want to be clever, instead of calling that h, I could be consistent and call it dy. It's up to you. I don't care. I do have a underline the word horizontally. That's going to be important. I do have a horizontal velocity, which is 32. What else have they told me? They've told me this distance here, which is 144 meters. In fact, I think they've told me dx. Okay. Oh, right away I can say ax is 0, ay is negative 9.8. Sorry? Vx is 32. What else? Dx is 144, and that's to the right, so it is positive. Oh, I know Vy initial is 0, because we're launched horizontally for a split second. We haven't started falling yet. Oh, which column do I have 3 pieces of information in this time? The horizontal. You know how I'm going to find t this time? Horizontal. Mr. Dueck, it didn't say find t. It said find how high the building. I'm telling you, to do any of these, your first goal is going to be to find time. So I'm looking for an equation that has a, v, d, and t in it. Why? This equation looks fairly familiar. Which one? Now, AJ's one step ahead. He said that's the equation. Actually, that's not what he read out. He said, well, since I know that's 0, I'm not even going to bother reading that out. I'm good with that. In fact, if you, in your homework, don't bother adding the half AT squared. I usually do in the notes so that when you're studying, you know that we did actually nuke it. Yes? And you're saying, how would I get the t by itself? Oh, geez, this is even nicer than the whole square root, whatever one we did previously. You're saying, Mr. Dueck, I'm pretty sure t is going to be dx divided by vx. It's going to be 144 divided by 32. I think you'd be right. 4.5 even? Wow, that's a fluke. Is it 4.5? It's AJ, so anybody else? It is, okay. Oh, let's write it up here. 4.5, 4.5, and then let's say they want us to find the height, which is dy. What do you mean plug and chug? Which equation can I now use?
dy.
The same one, but with y's. Yep. Okay, and yeah, you're right. The d is already by itself. It is plug and chug. Cool. In a nerdy sort of a way. I agree. So it's just going to be a half times negative 9.8 times 4.5. You're going to get a negative answer because this equation isn't actually giving you the height. It's giving you the displacement. But for what it's worth, when I tell them the height, I'll call it positive because I don't look at a building and say, oh, that building is negative 83 meters high. Right? Height's a scalar. But I do like the fact that the equation is actually saying, oh, by the way, you did end up below from where you started from. Hello. Nature knows what's going on. I forgot the squared. Wow, that would have been dumb. Squared! Do you get negative 99.2? And I'll just make a final height equals positive 99.2 meters. Okay? So far we've looked at two types of questions when we're launched horizontally. I can give you the height, find the range. I can give you dy, find dx. I can give you dx, find dy. And in fact, giving you dx, find dy, you may have noticed the math was a lot easier. It was a lot more plug and chug. Kind of nice. Probably you can expect one of each of those on your test. What else? Ooh, let's up the ante a little bit. Turn the page. Example 4. A projectile is launched from a 225-meter high cliff. Cool. With a horizontal velocity of 54 meters per second. Cool. A says, what's the range? We've done that. Okay. B says, what's the horizontal component of the velocity just before impact? I know after impact it's all 0 because it comes to a stop, but just before impact. C says, what's the vertical component just before impact? And then D says, what's the impact velocity, magnitude, and direction? Ooh, this is good vector stuff. I left you a whole page, I hope, yes, to write on? Or a whole half page? Yeah. Cool. Here we go. Suggestions? Nope. Okay. This one, my picture is going to be a little smaller because I have a feeling I'm going to need more room to show work. 225. No, not 225, Mr. Dueck. That's a little fast. 54 goes there. 225 goes there. Sheesh, that would have been silly. Horizontal, vertical, AX is 0, AY is negative 9.8, VX is 54, VY initial is 0. By the way, you may notice there is a 0 in each column, just occurring in different locations. Oh, and they gave me a vertical displacement, but Tanisha, I'm not going to write 225, what am I going to write? Negative, good. You'll remember for the rest of the unit. For the rest of your life. Perfect. And I want to find time. In the interests of saving time to find time. Shut up. In the interest of saving time, can we go straight to, we know that time equals, it was the square root of 2 dy over ay. Did I do that right from the previous couple of pages? Is that right? Yeah? Which is going to be the square root of 2 times negative 225 divided by negative 9.8. It's going to be the square root of 45.9, 6.7763. Did they ask me to find time? Then I'll carry a few extra sig figs even right now. I'm going to go 6.7763 seconds. Let's answer part A. They want the range. They want that. Which, oh yeah, we can cancel out the half AT squared. That's just going to be Vx times t. It's going to be 54 times 6.7763 times 54. 365.9. Let's call it 366 to 3 sig figs. Meters. B. I want you to visualize what the velocity, what the impact velocity of a horizontally launched projectile looks like. Watch. Look up. Watch. Did you see it hit the ground? Fall back here, Elijah. I don't know if you saw. You had a good view. It hit the ground at an angle. Did it hit the ground like that? Did it hit the ground horizontally? It hit the ground at an angle. I think if we talk about the impact velocity as a picture, it looks like that. It might be slantier, it might not be quite so slanty, but I'm telling you, William, it is slanty. But I don't think of it that way. I actually think of it as having a horizontal component and a vertical component. Just like we've been doing all along. By the way, why did I put a final on the Vy, but I didn't put a final on the Vx? Yeah. Okay, Vx isn't changing, but I'm telling you, Vy is. So now let's start to answer questions. What did B want me to find? You know what? I'm telling you, I know what that is. The horizontal component just before it hits the ground is 54, right? Right? In fact, over here where I've drawn this picture, I'm going to go equals 54. What does C want me to find, William? Ah, now that vertical component, my friend, that's changing. That's going to be Vy final. So now let's think vertical. What else do I know vertically? Well, we already said Vy initial. What was Vy initial? 0. Oh, and I do know time of flight. What was time of flight? 6.7763. Ooh, and I know AY is what? Now, I also do know dy, but I think that there is enough that I can find the final vertical velocity, not the final velocity, because the final velocity is slanty, but the final vertical velocity just before impact. There is an equation that has v final, v initial, t, and a in it, and I even think it has the v final by itself already, doesn't it? Which one, Tanisha? So I'm going to add y's in there for everything, but you're right. It's initial plus AT. It's 0. I'll write the 0 in our notes. In your homework, you can certainly skip writing the 0, Jordan, but we'll put that in so we remember what the heck we did. Plus negative 9.8 times 6.7763. Horizontally, just as it hits the ground, it's traveling sideways at 54 meters per second. How fast is it traveling vertically? Negative 9.8 times 6.7763. What's the negative in front telling me, by the way? Which way vertically are we traveling? Down. Down. Sure. Negative 66.4? I don't know, is there a squared anywhere in this equation? This is not VF squared equals VI squared plus 2AD, that one. Put it face down on the appropriate block, thank you. Oh, okay. Okay, I totally care. Hey, let's put that on our triangle too, Hakeem. So we know this is 66.4. Why didn't you put the negative on there, Mr. Dueck? I did with the arrow. That is showing negative, yes? By the way, a comment on the vectors test. I noticed a number of you aren't putting arrows on your diagrams. That's a terribly, 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 terribly bad habit to get into. You want to avoid that. You want to avoid that. You want to make sure on your vector diagrams you do put arrows. There's about 10 of you. I wrote little notes and had some fun with it. How can I find out how big V final is? Pythagoras, holy smokes, math 8! Really? So, D says that's going to be, well, VF squared is going to be 54 squared plus 66.4 squared. $54 squared plus, oh, I got this answer stored on my calculator, squared. And although it's negative, when I square it, I'll lose a negative anyways. I don't care. Square root. It's going to be traveling at an angle 85.6 meters per second. That's the speed. Did part D say find the speed just before impact? And direction. At. Now, I think the direction, AJ, my friend, is going to be that angle there. Which trig function? Let's see. Opposite, adjacent. Yeah, the one that showed up most often. Tangent. So let's do that over here. We're going to have tan theta equals opposite over adjacent. Inverse tan of 66.4 divided by 54. 50, you know what, I'll call that 51 degrees. 51 degrees what of what? Well, I can't say south of east, because I haven't given you is that right? 54?
Yeah.
51, sorry? Is that right? I can't say south of east. I haven't told you necessarily that this is to the north or above or below. So here's how we write this. We have been talking about horizontal and vertical. We would say below the horizontal. We're saying, oh, you know what? The angle that you found is that one there. Start out going straight horizontally and you went below. What if you were finding an angle and you went like this? You wouldn't call it below the horizontal. You know what you would call it? Above the vertical. Above the horizontal, yeah. I like this question. I like this question. I like this question. This is much tougher. By the way, I like every single question I've done. You'll see them all. This one is a nice advanced one because now you're actually saying, oh, not only can I find the range or the height, I can find the velocity right at impact. In fact, you can find the velocity, magnitude, and direction at any time during the flight if you want to. And now we're starting to do some trajectory mathematics. The mathematics of artillery. Not that we use artillery much anymore, it's all computerized, but this is some of the stuff that they were working out in World War II with cannons, back when they still used them. Homework. You can do number 1. You can do number 2. 3 is good. I think I'm going to be assigning most of it. 4 is good. 5 is good. 6 is good. Yeah, I think I will be. Let's see. Yeah, 7 is good. 8 is good. 9. Yeah. 10. Now, in number 10, well, first of all, in number 9, it looks tough, except I gave you something in the question. I gave you time, which is what we were almost always trying to find. So when you break up your column into horizontal and vertical, after you've done AY and AX and VY and VX, you can also put time equals 3.2 in both columns, which means you're going to find, oh, I've got 3 things in either column. I got lots of options to find the 4th. Actually makes it way easier. I haven't done one like that. See if you can figure it out. Pause. Have I got a good video?